Comprehensive ethogram for the American lobster, Homerus americanus. Ethograms are used in the study of ethology to help researchers understand the behaviors of animals. Comprehensive ethograms, in particular, are a useful tool to provide the basis for investigating relationships between the target species and how or why behaviors are performed, behavioral interactions within a community, identifying behaviors that can assist in conservation, and utilizing behaviors for more effective management. At its core, an ethogram is a catalog of behaviors, with each behavior described in detailed and objective language. This is done so that, in theory, an ethogram could be picked up by anyone and used to accurately identify the behaviors being displayed by the target species. My target species is the American lobster, Homerus americanus. The American lobster is a massively abundant benthic marine predator and is an incredibly important fishery in both Canada and the United States. Because of this, it is vital to understand the ecological role of lobsters and how resource exploitation affects their communities. However, the majority of previous research on lobster behavior occurred within laboratories, which can affect when and if lobsters display certain behaviors. Additionally, different studies often created different behavioral descriptions, which introduce inconsistencies, especially if those descriptions lacked any clarifying visuals. So my goal was to develop a comprehensive ethogram of the American lobster that combines written behavioral descriptions with a video library that shows examples of both wild and captive lobsters. To do this, I first needed to become familiar with lobster behavior, and that means watching a lot of lobsters and reading a lot of descriptions. For the video sources, I used videos drawn from a larger study of lobsters foraging in the field, which used cameras mounted on tripods. As you can see from this video, the camera is pointed towards the seafloor and has about a 2 meter by 2 meter field of view, with the bait bag kept in the center by the ropes attached to the tripod legs. And I was also provided with a 25-minute recording of lobsters in the aquarium, because lobsters have some shelter-restricted behaviors, which the tripods were not set up to capture. I undertook a literature search to locate as many unique published ethograms as possible. I used both papers and books to form the basis of my final ethogram. Together, I use all of these sources to create two types of behavioral descriptions: behavioral units, which characterize basic movement patterns and are underlined, and behavioral sequences, which use behavioral units to build more detailed descriptions of behavioral patterns and are italicized, and are further grouped into 12 behavioral contexts. So this ethogram is a little different from most, as I split it into behavioral units and behavioral sequences. I did this because lobster behaviors are modular, because they arise from a set of basic appendage and tagmata movements. Each appendage has multiple joints, which allows each maxilliped, caliped, and periapod to extend and bend and sweep, etc., etc. So I followed nature's example and made similarly modular behavioral units to describe each of these basic movements. However, it would quickly become tedious and unwieldy to describe complex behavioral patterns using just the behavioral units. So instead, I made it so that the behavioral units could be combined in different ways, thus creating the behavioral sequences. These behavioral sequences can also be combined with other sequences and units to describe even more complex behaviors. To illustrate this, let's look at an example of two different behavioral sequences that use a couple of the same behavioral units. Then we'll see these two behaviors in action. The aggressive lobster will be performing a threat behavioral sequence called lunge threat. This will involve it using periapod walk to move forward, followed by a caliped extend towards the other lobster. These aren't the only behavioral units it will display, but they're the ones we're focusing on. The other lobster will be performing a defensive tail tap. It will start off by using periapod walk to move backwards, followed by an abdomen tail tap, and holding out its calipeds in a caliped extend. So this is how the same appendage movements can be modified and combined to produce different results. Let's take a look at the video. As you can see, the lobster at the top of the screen will be displaying the lunge threat, and the lobster lower down will be displaying the tail tap. Periapod walk and caliped extend will show up in the boxes when the lobsters display them. And this video will also be showing up again later. And another lunge threat, tail tap. So now that I have videos of lobsters and descriptions of their behaviors, it's time to start constructing the comprehensive ethogram. I developed steps to evaluate published descriptions, which are as follows. First, there were multiple studies that ended up using the same name to describe different behaviors. This would obviously cause confusion, so we need to make sure each unique description is given a unique name. Second, there were also many descriptions that describe essentially the same behavior, but with minor variations. Such descriptions had to be consolidated to remove redundancies. And indeed, many of the redundant descriptions ended up contributing to observed variations within each behavior. Third, since we are dealing with animals that inhabit a variety of environments, we need to eliminate any specific environmental references. This prevents the ethogram from having separate wild and captive entries. And any animal or item that a lobster might interact with is replaced by object as a placeholder. This keeps the ethogram from becoming bloated with separate entries for grabbing a rock or a fish or another lobster. Fourth, consistent anatomical terminology will need to be used to make each behavioral description as clear and comprehensive as possible. And finally, some behavioral descriptions had to be rewritten to ensure that it describes the behavior of a single lobster. In some cases, I had to break up published behavioral descriptions into several separate descriptions in order to maintain the focal animal requirement. To illustrate these 5 steps, I'll walk you through the process using the behavioral sequence lunge as an example. The first step requires each behavioral description to have a unique name, which means getting rid of definitions that can't be consolidated. All 6 of these behaviors were given the name lunge. However, if you look closely, you'll notice that these 4 descriptions in the top row all share a key behavioral similarity that these bottom 2 descriptions lack, making these 2 clearly different descriptions that cannot be combined with the top 4 descriptions. And indeed, they ended up being incorporated into 2 different behavioral descriptions. With those 2 out of the way, we can focus now on our second step, consolidating the remaining 4 descriptions, which is characterized by the lobster quickly striking with its callipeds at an object. Note that we've now replaced opponent with object, thus fulfilling the third step of eliminating environmental references. Our fourth step involves using consistent anatomical terms, which means changing claws to callipeds. Our fifth and final step requires each behavioral sequence to accurately describe the actions of a single focal animal. In this case, the published descriptions all maintain the focal animal perspective, which made for a nice and clean final behavioral sequence description. Which then brings us to the finished behavioral description and its video example. I've slowed this video down and put it on a loop to give you a chance to see what's going on. The white arrow is pointing to the lobster that will be performing a successful lunge. It'll run forward a couple steps and then grab the antenna of the lobster on the bait bag. We'll be seeing this exact lobster a couple more times because it really brings the drama to the bait bag. As with published descriptions, novel behaviors also needed to follow a clear criteria to ensure consistency. In addition to following the rules laid out for the published descriptions, behavioral patterns could be considered novel if it lacked any resemblance to previous descriptions. However, similar behavioral patterns could be considered novel if they used a different appendage to perform a similar behavior, used the same appendage and behavior but targeted a different body part, this criterion is specific to grooming, performed the same pattern but with a distinct distribution of speed, or performed a similar pattern but with a distinct distribution of the extent of motion, such as is seen in this example, of a tail flip and a tail tap. The tail flip on the left includes the full range of motion, whereas the tail tap on the right has only a partial contraction of the pleon. And yes, both of these videos come from the same tripod deployment. This can also include new combinations of previously described behaviors. For example, lobsters in captivity will use a behavior called scissor during their fights, which looks like this. And she's gonna bap. Beautiful. But in the field videos, lobsters were observed combining scissors with other behavioral patterns to explore their environment in a previously undescribed way, as can be seen in this behavior, which I've called maral exploration. This video comes from the same deployment as the lunge video I showed earlier, and the tripod leg that I've circled is going to be the target of 4 maral explorations, each preceded by an identifier number so we can keep track. So 3 lobsters will be performing the 4 maral explorations, with that first lobster coming back to perform a cautious encore at the very end. Each lobster adopts an aggressive posture, approaches the tripod with callipeds and a maral spread, and then performs a scissor against it, before either continuing to investigate the tripod or tail flipping back. Also, this third lobster to perform the maral exploration, this guy coming up here, is the same lobster that performed the lunge we looked at earlier. Just keeps bringing the drama. And this last lobster is the same one who started the whole cascade of mayoral explorations against the tripod leg, and then gets chased off by drama lobster. There's a little tap, and there starts the chase. Using these criteria, novel behavioral patterns are found in nearly every context I looked at, from feeding and travel all the way to fight. In total, I described 98 behavioral units, of which 75 have an accompanying video example, whereas 12 behavioral units were observed and described, but the quality of the videos were too poor to use as examples. And only 11 behavioral units occurred only in the published literature. For the behavioral sequences, I described a total of 119 sequences, of which 37 had not been described before. A total of 91 behavioral sequences have video examples. Only 4 behavioral sequences were observed and described but lacked quality video examples. And a total of 24 behavioral sequences come solely from the published literature and went unobserved in my field videos. Out of the total of 217 behavioral descriptions, only 51 descriptions lack a video example. All told, 23 behavioral units and 28 behavioral sequences are without videos. The greatest reason for these gaps in the video data are due to the tripod apparatus. It was impossible to record larval behaviors because lobster larvae live on or close to the ocean surface, whereas the tripods were designed to stay on the ocean floor. Behaviors that occurred inside shelters were also impossible for the tripod apparatus to record, and so laboratory videos had to be used to fill in some of the gaps. And reproduction-related behaviors primarily occurred within shelters, so again, laboratory videos were necessary. Another reason for the lack of videos had to do with visibility issues, particularly in sandy bottoms or after storms. As a person who spent all day, every day watching lobsters, I could often pick out behaviors in these poor visibility conditions, but such videos would be extremely poor examples to place in a video library for new crustacean initiates to attempt deciphering. And lastly, some behaviors may only occur around places that lobsters congregate at for the purpose of sheltering and mating, so-called lobster reefs. For example, cheliped locks may be necessary in a more permanent social setting as a way to identify individuals and maintain hierarchies, which is something that a temporary source of food would be unlikely to trigger. In addition to the formally described videos, I also saw a whole host of interesting and possibly new observations, of which I'll share 6 of my favorites. One of my absolute favorites is watching lobsters try to carry or drag items away. This video is from one of our pilot trials, which is why it's a bit shaky, and we use cat food to bait different bags and containers. And this cat food pate held its shape very well, and you can see that the lobster was able to stick its periopods inside the container to pull out the puck of cat food and then take off with it balanced on its chelipeds. It's amazing. I love this guy. Here he goes. And this is from our very first video in the field, where Russell literally just plopped down a tripod and opened a can of cat food underneath it. You can see that the lobster hooks its third maxillipeds on the can and starts walking backwards, and would have gotten away with it too if it weren't for that middling lobster. But this also raises some interesting questions. Do lobsters cache their food? Do they bring food back to their shelters? Juveniles in labs have been reported carrying their food back to their shelters, but do adults in the field do it too? Another favorite observation is of large lobsters ignoring small lobsters. The top arrow is pointing towards the large lobster, and just for context, that container it's sticking its cheliped into is about 7.5 centimeters, or around 3 inches deep. The bottom arrow is pointing to the smaller lobster, whose carapace length is maybe 8 centimeters, just barely legal. So the little lobster goes jumping after a fish, and then runs smack dab into the dragon, who just does nothing. Kind of startles a little bit. And this begs the question, are lobsters in the field less aggressive or cannibalistic than we thought? And speaking of lobsters and their food, something that we don't see in laboratory settings is food guarding. Lobsters in the laboratory just don't seem interested in guarding or fighting over food. But one of the most common things that I've seen are lobsters spending a lot of time apparently chasing other lobsters away from the bait bag. And yes, the arrow is pointing to our drama lobster from the lunge video, who's chasing everyone away from the bait bag. Oh, gonna have to fix that. It's supposed to play earlier. All right, doing some cover object, and then more aggressive posturing. So what is it about lab settings that makes lobsters apparently less aggressive around food sources? Which segues nicely into lobster fights, a thing that we can easily trigger in the lab but seems to be rare in the field. This is the first video where we saw a full-on lobster brawl, which occurs between the two lobsters circled here. These two lobsters were my main source for describing a new fight behavioral sequence that I termed Merrill Tango. You can also see them performing the fight behavioral sequences wrestling and several scissors, and also a couple more really good Merrill Tangos. So we got some nice scissors going on, and here we go. Perfect Merrill Tango. And then one of them just kind of loses track of the other. While I can't say that this is the first time a lobster fight has been seen in the field, I can say that my ethogram is the first time a fight has been described in the field. This next one is a pattern of behaviors that I think deserves its own project to investigate, especially in combination with the very last observation. So this particular video is a short example of a behavior that tends to take several minutes in real time. The arrow points to the lobster who's doing the circling, and I've sped this video up so it's a little hard to see when the circling lobster pauses or sweeps its antenna. Generally, the circling lobster usually adopts a neutral posture with lowered chelipeds and stretches out its chelated periopods on the substrate and in the general direction of the food source, like it's feeling for scraps. It's also pretty common for the feeding lobster to display aggression at the beginning of the interaction, which sometimes seems to taper off, and sometimes it doesn't. I've watched one interaction that lasted almost an hour, and the feeding lobster gave no quarter to the circling lobster. All of which makes me wonder what's going on. Is this an example of appeasement attempts to access food? Or is the circling lobster trying to displace the other lobster without fighting? And this leads me to my last interesting observation, which usually takes place after some circling. It's a little hard to see here, but there is one lobster inside each circle, and they're feeding on a whole mackerel that they ripped open earlier. This simultaneous feeding bout didn't last very long, but they did have several of them. This one was the longest and easiest to see. Now this really intrigues me, especially since I've seen small subadult lobsters cozied right up against a much larger lobster, both of them feeding, with no hint of aggression. One possibility is that the lobsters who feed together with little or no aggressive behaviors might be familiar to each other in some way. It might also be the result of a successful appeasement attempt. I often saw simultaneous feeding after some bouts of circling, but not always. The video I just played didn't have any prior circling, but it's entirely possible that a different set of behaviors was used to gain access to the fish. It's also possible that there are specific qualities of prey items that might encourage simultaneous feeding and discourage aggression. Let's take a look at how the comprehensive ethogram could be applied to determine if the circling and simultaneous feeding behaviors that we observed might be part of a possible suite of appeasement behaviors that lobsters may utilize to de-escalate agonistic interactions around food sources. First, we need to identify aggressive behaviors that are easy to identify, most likely to occur, and can reliably indicate aggression levels. This first set of aggressive behaviors are extremely common and are often displayed in a slow and exaggerated fashion, making them easy to identify and are reliable indicators that an agonistic interaction has started. Basically, if at least two lobsters are near each other, you can bet on aggressive posture, with its distinctive Merrill spread being displayed, either on its own or incorporated into a fast approach or slow approach. If one lobster is feeding and another approaches, it's highly likely that the feeding lobster will perform cover object, and then direct a sword and shield at the approaching lobster. The second set of threat behaviors are less common, but still very distinctive. In the videos from the field, lunge threats and scissor threats were performed by lobsters that were approached while feeding, and frequently after the approached lobster had already displayed one of the more common threat behaviors, one or more of the more common threat behaviors. So these two behaviors would also be good candidates for measuring increased aggression levels. And while very cool, fight behaviors were rarely seen in the field, and this rarity makes these behaviors less useful for our proposed application. This may be different in a lab setting, but in this field example, we'll exclude them. So now on to the potential appeasement behaviors. Appeasement behaviors haven't been studied as much as aggressive behaviors, So we have fewer known appeasement behaviors to choose from, and most that we do know comes from studies on courtship behaviors. The most common and distinctive behaviors we can expect to see are the apparently neutral approach, neutral posture, which is primarily characterized by closed and lowered callipeds, a body posture that is lower to the substrate, and slower execution of behaviors that may incorporate some apparent hesitancy, such as walking a few steps backwards from the aggressor. The next set of behaviors are less common and more dependent on the behavioral feedback the appeasing lobster receives from the aggressive lobster. If the aggressive lobster has performed one of the uncommon threat behaviors, the appeasing lobster may attempt a circling approach. If the aggressor continues performing high threat behaviors, I'm going to change that to uncommon threat. The appeasing lobster may react by adopting a submissive posture. But if the aggressor just displays common threat behaviors or stops displaying any aggressive behavior, then the appeasing lobster may attempt to feed at the same food source as the aggressor. So now that we know which aggressive behaviors we're looking for and what our appeasement candidates are, we can get an idea of if these are successful appeasement behaviors by how often they successfully de-escalate aggression or if they increase simultaneous feeding. That's awkward. One way to look at this is by quantifying aggressive escalations or de-escalations in response to the proposed appeasement behaviors. If a feeding lobster moves from non-agonistic behaviors to common threat behaviors in response to the presence of another lobster, then we know that an agonistic interaction has started. And if that lobster begins performing uncommon threat behaviors, then we can see that their aggression has escalated. If, on the other hand, the non-aggressive lobster begins displaying identifiable appeasement behaviors, and the aggressive lobster stops performing uncommon threat behaviors, or even halts common threat displays altogether, and returns to non-aggressive behaviors, then we can say that their aggression has de-escalated. This kind of study may also give us a chance to observe if lobsters have other appeasement behaviors or different appeasement strategies for diffusing conflicts around food sources. Another way to measure the possible effectiveness of the proposed appeasement behaviors is to compare the duration lobsters spend in agonistic interactions with the amount of time spent feeding together. If two lobsters begin an agonistic encounter with the feeding lobster displaying aggressive behaviors and the new lobster primarily displaying appeasement behaviors, and the encounter ends with simultaneous feeding, then the interaction could be considered an appeasement success. If, however, both lobsters display aggressive behaviors and the new lobster displaces the first lobster, it could be considered an aggression success. And if the new lobster fails to feed at all, then it would be recorded as a failure. As I hope I've shown, there are a lot of exciting ways that this comprehensive ethogram could be used. However, there are a few more basic projects that I'd like to focus on. The first is completing the comprehensive ethograms video library, which can be done with videos from both lab and field sources. As we saw earlier, it's so close to being finished. Another project involves investigating lobster reefs. We don't have a lot of information on what lobsters do when they're not raiding lobster traps. And we've got some tantalizing hints from both the lab and field that they may have more of a social life than expected. Either finding or creating a lobster reef would provide the first steps to answering some of these questions. And lastly, there's a serious dearth in larval observations. It is the least studied life stage in terms of behaviors, and it is highly probable that we may be lacking in behavioral observations. Even so, as it stands now, the comprehensive ethogram will help expand our understanding of the ecological role of the American lobster within its nearshore ecosystem. And by incorporating both published and novel behaviors into a single ethogram, and by consistently using anatomical terms, future ethogram terminology will also become more standardized. I also hope that this ethogram will provide incentive for other researchers within Decapoda to create comprehensive ethograms for their own study species, which we could then gather together in one searchable place on the internet, like a Wikipedia for decapods, Decapedia, if you will. And finally, I hope that this comprehensive ethogram becomes a reference guide for the American lobster's behavior that allows for greater consistency among researchers and is used to accomplish a variety of different research goals. I would like to give my sincere thanks to the multitude of people and organizations without whose time, expertise, patience, and support I could not have gotten to this point. Okay, so that's 24 seconds. Questions! Questions! Trillium being adorable. We don't need to keep seeing